Hello friends, in this tutorial we are starting with the data structures. So basically these data structures get categorized into two parts. First linear and the second non-linear data structures. In linear data structure, stacks, queues and the linked list are there, whereas in a non-linear data structure, trees and the graphs are there. So basically in stack, queue and the linked list, elements will be stored in a linear fashion, whereas in a trees and the graphs, data will be stored at a random position. So today we will start with the first data structures, that is a stack. So in this tutorial, first we will see definition, how to define a stack, then we will see the example of a stack, and then the important concept, that is the top of the stack. So let us begin. First, the definition of a stack. Stack, it is a linear data structure where data will be stored in a linear fashion. And always remember, whenever you are defining any data structure, you always have to begin with it is an ordered collection of an elements, as data structures are nothing but a way to store your data, and if you are storing a data, then it is always collection of an elements. Okay, so first start your definition with it is an ordered collection of an elements. Then in a linear data structure you will be having ends, okay, for the insertion as well as for the deletion operation. Whereas stack, it is a structure where you will be having only one end which is open and one end which is closed. So obviously if the end is closed, then no insertion, the deletion operation can be possible. But whichever end is open, from that end you can insert your element, and from that end only you can delete your element. So meaning is that stack provides only one end which is available for the insertion as well as the deletion operation. Now combine all this concept to define your stack. So basically start your definition with it is an ordered collection of an elements, in which elements can be inserted from one end and elements can be deleted from the same end, called as top of the stack. Okay, important part in this definition is top of the stack. To understand this concept, consider one example. You are having one bucket, okay, and that bucket you have to insert your book, or you have to put book inside that bucket. Okay, so first you are having first book, then obviously that book will goes at the bottom of the bucket. Then on the top of that first book you will arrange second book, then third book, then fourth book, then fifth book, up to the capacity of that bucket, right? So one end it is closed and one end it is open. Now you want to remove, okay, you have to remove that first number book. So whenever you want to remove that book number 1, you always have to remove first fourth book. Okay, why? Because one end closed and there is only one end from which you can insert as well as you can delete, right? So whenever you want to delete bottom book, you always have to remove your first 4 book, and then only you can remove your first number book, right? So this is the concept of stack. Okay, so this is the concept of stack, which is called as last in first out concept. Okay, just consider this diagram. Here in this diagram there are 5 books that are arranged one on top of the another, right? At the bottom there is a book number 1 and at the top there is a book number 5, right? First you have inserted 1, then book number 2, then book number 3, then book number 4, and at the last you have inserted book number 5. So remember which book you have inserted at the last. You have inserted book number 5 at the last. According to the principle of a stack, or the working principle of the stack, whichever element you have inserted at the last will be the first element which will goes out. Okay, so which element or which book you have inserted at the last? You have inserted at the last book number 5. So book number 5 will be the first element or the first book that will get deleted or that will get removed from your list. Getting? So this is called as a last in first out concept of the stack, right? Now we will see the example. Consider you have to create one stack of 5 elements, and you have to perform 2 operation, insertion as well as deletion operations on these elements. Okay, and you have to insert number 10, 20, 30, 40 and 50 into the stack, right? So first element from the list will be the first element that goes into the stack. So first element is 10. Then on the top of 10, 20 will get inserted. On top of 20, 30 will get inserted. On that 40, and at the last your 50 element will get inserted. Just pay attention here. First element that was inserted was 10, and the last element that was inserted is 50, right? Now we will see the deletion operation in a stack, right? So you have to delete numbers from the stack. So as we have seen, the working principle of a stack, that is last in first out, right? So in the insertion we have inserted 50 at the last. So 50 will be the first element that goes out of your stack. After 50, 40 will get deleted, then 30, then 20 and then 10. Always remember, whenever you are talking about the stack data structures, then your last element will be the first element that goes that gets deleted by default. Okay, user will not have choice here to delete element. By default, the last element which you have inserted will be the first element that goes out of your stack. This is due to the working principle of a stack, that is a last in first out concept. Okay, now one of the important concept of a stack, which is called as a top of the stack. So basically, what is this TOP? Okay, so top of the stack, it is a special pointer which is given by a stack, which denotes current position of the element in the stack. Okay, so remember here one thing, whenever your stack is empty, at that time always and always your top will be equals to -1. Whenever there is one element in the stack, your top will be equals to 0. Then your top will if you are having two elements, then your top will be equals to 1. Just consider this diagram. As you have inserted first element, that is a 10, your top is equals to 0. Then you have inserted 20, then your top is equals to 1. Then you have inserted 30, then your top is equals to 2, and so on. Okay, now consider, we will see the simulation of this insertion and the top of the stack position, right? So just consider the first figure, right? As you have seen, as you can see, the capacity of this stack is 5 elements. Okay, and right now your stack is empty. As I said earlier, whenever your stack is empty, at that time your top will be always and always equals to -1. Then you have inserted 100, and then your top is equals to 0. Then you have inserted 1, then your top is equals to, then you have inserted 200, then your top is equals to 1. Then you have inserted 300, top is equals to 3. 400, top is equals to 3. You have inserted 500, top is equals to 4. So remember one thing, whenever stack is empty, at that time top is equals to -1, and whenever you are inserting element, your top position, it gets incremented. Okay, now see the simulation of this deletion operation. As you have inserted all the elements, right? So stack is full, and your top position is at the top of the stack, right? That is top is equals to 4. Then you have deleted 500, then your top is equals to 3. Then you have deleted 400, then it is 2. You have deleted 300, then it is 1. Then you have deleted 200, then your stack top position is at 0, and you have deleted 100 also, then your stack is empty and your top is equals to -1. Okay, so just remember here one thing, whenever you are inserting an element, increment your top, and whenever you are deleting element, decrement your top. Okay, and again see the previous diagram, and we will talk about the top of the position, right? Top position of the top. Consider the second diagram. In second diagram you have inserted 100, and here your top position is equals to 0. Then consider diagram number 6. Here you have inserted all the elements, right? And your top position is at the 4. Then consider the deletion diagrams. In deletion diagrams, consider diagram number 3. Here position of the top is at 2. Okay, and consider the second last diagram. Here top is equals to 0. Okay, so actually